Hi there and welcome to this video for Senior Physics on Electrostatics and Electricity. In this video we're going to explore Coulombs Law. Now Coulombs Law was basically a law put forward by Charles Auguste de Coulomb. Now he was a French mathematician who worked with static electricity. As a result, his surname was given as the main unit for charge. Now 1 coulomb is equivalent to 6.25 times 10 to the 18 electrons. Now this comes by dividing 1 by the charge of an electron, which is 1.6 times 10 to the negative 19 coulombs. That gives us 6.3 times 10 to the 18 total electrons. Now obviously the charge of the electron was not found until Robert Millikan did his famous oil drop experiment. However, from this we have noticed that each electron has a specific charge, and it's the interaction of these charges or a number of charges which causes the process of electricity. Now Coulomb's law helps us to describe the electrostatic interaction between electrically charged particles. It basically looks at the force which is going to occur between these particles. So if you can see down in the bottom diagram, we've got two charges, Q1 and Q2. Now in this case we've basically got one acting in one direction and one acting in another. As a result, there is a force between these two charges. This force may be a repulsive charge or an attractive charge. Depending on the distance that the charges are placed will depend on the size of the force. The way I've explained it in class is like two magnets. Take two North Pole magnets and try and put them close. The closer you put them, the harder it gets to actually push them together. Why? Well, there's a force between each of the poles. Now, because the poles are the same, this force is repulsive. The closer they get, the more force there is to repel them. Likewise, if I took a north and a south pole and placed them together, as I get closer together, the force of attraction, because they're opposites, actually increases. So the distance is very, very dependent on the, or links very, very nicely with the force. The closer the distance gets, the greater the force is going to occur. Now, this, when put together, produces a curve. This curve is, as we see here, an inverse square curve. And this inverse square curve is a classic curve which can be utilized in a variety of different scenarios. It works very nicely for electrical charge. It also works for gravitational, the force of gravity acting on an object as it moves away from the planet's surface. So from this, a relationship was devised where F is proportional to the two charges combined divided by the inverse square of the distance. So as a result, we get F is proportional to Q1 times Q2 divided by the distance D2. From this, a mathematical relationship can then be devised where we can find a constant K looking at the gradient between the force and the distance. So overall, K has been given as a constant of 9 times 10 to the 9 Newton meters squared per centimeter per coulomb squared. Basically, force is going to be measured in newtons and charge is in coulombs, and the distance is measured in meters. Note that the force in this scenario is a vector, so direction can be important, and you'll see as you follow through on the activities in this post, I put up an exemplary video which shows you where we've got force acting as a vector, but more on that later. So let's have a look at a very, very simple example that will hopefully show you how we can work through the Coulomb's law equation. So I've got 2-point charges, one measuring 2 coulombs and one measuring 3 coulombs, which are placed 75 centimeters apart. I want to determine what is the force acting upon them. Well, in order to solve the problem, I need to write down what I know. Well, I know my first charge is 2 coulombs, my second charge is 3 coulombs. The distance is 75 centimeters. I need to convert that into meters first, so divide by 100 and I get 0.75 meters. I also know that my constant is 9 times 10 to the 9 Newton meters squared per coulomb squared. So let's write down my algorithm. So I get F equals K times Q1 times Q2, all divided by D squared. If I substitute in the numbers that I've got at the top, I get 9 times 10 to the 9 times 2 times 3 divided by the distance squared, which is 0.75 squared. The result is I get this large force of 9.6 times 10 to the 9 newtons. That's a very, very simple example which shows how we can incorporate Coulombs law. What I'd like you to do now is go and watch the exemplary videos where I've got another simple equation for you to work through, incorporating microcoulombs, 1 times 10 to the negative 6, which allows you to do more adjustment, and then a more complex A-grade question where you have to look at a force in the form of a vector. Well, I hope this has explained Coulombs law to you. Thank you for watching, and I look forward to you joining me again. Bye for now.